Hello guys, this is P Chand. Welcome to my mathematics class. Let's see the today's topic. Today's topic is binomial coefficients. I have taken here problems on binomial coefficients. One video I have already made on binomial coefficients and its properties. Today I have taken very important questions from the examination point of view. Yes, if you are in a grade 11 and 12, especially 12 and studying with mathematics, definitely this video going very helpful, useful to you. So let's see how to prove these questions. All right, so I'm going to tell you the proofs of these questions one by one. Okay, so let's move into the question number first. If 1 plus x raised to power n is equal to c0 plus c1x plus c2x square plus dot dot plus cnx raised to power n, prove that c1 plus 2c2 plus 3c3 plus dot dot plus ncn is equal to n times 2 raised to power n minus 1. Okay, no problem. So I'm going to make you easy. First, left hand side, I'm taking left hand side. On the left hand side we have c1 plus 2c2 plus 3c3 plus dot dot plus ncn. Here listen to me everybody, here c1 means nc1, right? C2 means nc2. C1 is equal to NC1. For simplicity, we have written C1. We write down, okay, in binomial coefficients only just C1, right? So C1, and here I'm going to use the formula of NC1 and factorial upon n minus 1 factorial 1 factorial. I've used this formula. NCR is equal to n factorial over n minus r factorial times r factorial. Okay, using this formula I'm going to write down in each term this way, plus 2 times, here c2 means n factorial over n minus 2 factorial plus 3 times n factorial over n minus 3 factorial and times 3 factorial plus, I have a space here, I don't have a so big black whiteboard, dot dot and plus n and cn means, okay, n factorial times n minus n factorial into n factorial. Okay, just we have used the formula of combination is equal to there, and we can n times n minus 1 factorial or n minus 1 factorial. 1 factorial is 1, so no need to write down there, plus 2 times n factorial n minus 1 n minus 2. You can expand up to n minus 2 factorial because in denominator we have factorial n minus 2, right? Now over here you write down the n minus 2 factorial and 2 factorial, you write down 2 times 1 factorial, right? Okay, or sorry, here 1 factorial you may write down, or simply 1 you may write down, as we know the 1 factorial is equal to 1. Okay, so here 3 times, here I'm going to I just think, okay, I'll get a space, okay, I'll try to n minus 1 and minus 2. Okay, I'm not going to get here space, so I'm writing here 3 times n minus 1 n minus 2 n minus 3 factorial over n minus 3 factorial and 3 factorial plus dot 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 plus n times here n factorial going to be cancelled out. Okay, and here 1 cancel and okay, over n minus 1 is a 0 factorial. Okay, is equal to, here cancelled, alright, cancelled, and here n plus 2 also cancelled. Okay, they can be cancelled, and here this also can be cancelled. You will have n minus 1 over 1 factorial, or simply n minus 1, you can write down, and a plus here. Okay, 3 factorial we can write down. Okay, 3 times 2 factorial, and 3 cancelled. Yeah, these two can be cancelled. You will have here n minus 1 and minus 2 over 2 factorial, and plus dot dot plus simply n, because 0 factorial is equal to 1. Alright. Mm, Now see, here and here also n. We have n in each term. We can take common, and common inside the bracket, you will get here 1 plus n minus 1 plus n minus 1. You will write on 1 factorial n minus 1. I think you are understanding. N minus 2 over 2 factorial plus dot dot plus here 1. Okay, if you see, this is the expansion of binomial, right? Expansion of binomial. We have to find out, okay, here 1. Started from 1. This means your first term is 1, and the last is also 1. This means you have also second term 1. Alright, and here 1 plus nx. Here instead of n, we have n minus 1. So this will represent the power of binomial, right? We can write down this way, n here 1 plus 1 raised to power n minus 1. So this is, okay, this is the expanded form of this binomial expansion. Okay, now otherwise, okay, you can check, okay, you can just expand, okay, this one, you will get same thing. Okay, 1 plus n minus 1, 1 factorial, n minus 1, n minus 2 over 2 factorial plus dot dot, you will get it, right? This is expansion. You will try yourself. You can expand this. Exactly, you're going to get this one, right? So is equal to n into 2 raised to power n minus 1. If you have any problem, you can see my all videos based on binomial theorem. You will get it. Is equal to 2 raised to power, yes, which was to be proved, okay, this one, and 2 raised to power n minus 1 is equal to right hand side. So easy way I have told. Each and every term I have explained here, I have not missed even single term. Okay, so I think you understood how to find the right hand side of this question. Okay, so clear. Let's move into the second question. Second question, left hand side. Second question, okay. Left hand side, I'm taking C1 minus to C2 plus 3C3, okay, sorry, here, minus dot dot plus n minus 1 raised to power n minus 1 Cn. I've taken left hand side of the second part of first question. Okay, see here, same, n factorial over n minus 1 factorial, 1 factorial, okay, 1 factorial. Here also I am going to use formula, and 2 times, okay, n factorial over n minus 2 factorial, 2 factorial, plus 3 times here n factorial over n minus 3 factorial, and times 3 factorial minus dot dot dot. I'm going to write here a lack of space, minus 1 raised by minus 1 here, n factorial over n minus 1, sorry, n minus n factorial, and here n factorial. Okay, so here we can write on n minus 1 factorial over n minus 1 factorial minus 2 times and n minus 1 n minus 2 factorial over n minus 2 factorial 2 times 1 factorial, or plus 3 into n minus 1 n minus 2 n minus 3 over here factorial n minus 3 factorial and 3 times 2 factorial minus dot dot plus here 3 dots I have used 3 dots I now n minus 1 raised to power n minus 1 here n factorial cancel 1 upon 0 factorial means 1 you will get as I told you in the first part, right? Is equal to, yes, same, only we have minus sign here, minus minus alternately, or cancel here n minus 2 to cancel this cancel here, you have n and minus 1 over 1 factorial and plus 3 cancel and minus 3 factorial these two terms can be cancelled. Okay, you will have okay n minus 1 and minus 2 over 2 factorial minus dot 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 plus n minus 1 raised to power n minus 1. Okay, so here n times so on n times, right? In each term we have n as okay multiple, so we can take n common here 1 minus n minus 1 and plus n minus 1 and minus 2 over 2 factorial minus dot dot plus minus 1 raised to power n minus 1. So it's a simple, okay, we have got idea. First term is 1, right, in expansion, and second term is minus 1 because and power is n minus 1 officially here n minus 1, right? This is also n minus 1 and here 1 minus 1 raised to power n minus 1. If we expand this, right, using binomial theorem, you will get this one. You're gonna get this one, okay, without any problem. Okay, you can try. Otherwise, if you have any doubt, n times 0 raised to power n minus 1, 0 raised to power means 0. Here n minus, okay, 0 raised to power n minus 1 means 0. So you are going to get here n times simply 0 is equal to 0, is equal to right hand side. So I think, okay, clear. So here in second part on the right hand side we have a 0, we have also got 0, right? So in each and every line I have written everything clearly, right? So I don't so think you have a problem. Second question done, right? So let me take done, and this is also done. I made here and okay circle with red color so that our equation will be highlighted, right? Okay, 2 questions done. Let's move into the 3 questions. Okay, question number third part. Okay, question number 1 3 third part of the question. First question not so difficult. Question number third, left hand side of third part. Okay, left hand side of the third part, little bit different question. C0 plus here to C1 plus here 3C2 plus dot dot and plus n plus 1 is Cn. Okay, see everybody here how to do. One thing, okay, from last term you can get idea because last term represents journal term. Okay, last term act as a journal term n plus 1 Cn. So you can break, okay, if possible, okay, term in this form, okay, n plus 1. N plus 1 n, here is n, here is n. So 1 plus 1, 1, you can, if possible, here, alright, and here like this way. And if you get, okay, 3, you can break 2 plus 1, C2, right? And like this way you can break, right? So from here we can get idea 0, here 1, okay, simply 0 you may write down. And you can, yeah, C1 you can break, okay, 1 plus 1 because, okay, 1 here, so whatever you have here, so you can write down here, and C1 we can write down also, but we can write down like this way 0 plus 1 C0, no need to write down like this, right? So C0 is C0, okay. And now 3, you can break 3 like this way, n plus 1 means 2 plus 1 officially, right? 2 plus 1 here, C2 plus dot dot plus n plus 1 Cn. So easy, not so difficult. Is equal to C0 plus, you can write down, just multiply C1 plus C1, and here to C2 plus C2, right? And plus dot dot plus NCN and plus CN. Oh, easy. I think you are enjoying. Okay. Now I'm writing, okay, first part, okay, and then C0, C0, C2, like this way I'm taking, okay, and first, okay, like this way C0 plus, so I'm choosing this one, okay, C1 plus, and then C2 plus, and dot dot, and finally I'm taking CM, right? Okay, I've collected in one bracket. Now remaining, I'm writing in another bracket. Remaining now, C0 taken, okay, C0 taken, right? Now we are left with C1 plus 2C2 and plus dot dot plus NCN. Okay, so no problem. Alright, yesterday I went to again last video. I have done the proof of this question. This is the sum of binomial coefficients, right? As a formula we can use, okay, while doing these type of questions, and its answer is 2 raised to power n. Sum of the binomial coefficients is equal to 2 raised to power n. You can just see, okay, in my earlier video, if you want to see how we have proved in easy way I have proved, right? 2 raised to power n plus, here, okay, C1 plus C2 C2 plus, okay, it's a time, okay, 2 times C2 plus, so dot dot n times Cn. Exactly the first one question. Exactly your first one. C1 plus 2 times C2 plus 3 times C3 plus dot dot n times Cn. Okay, right? So I have proved. Just now we have done. You are the witness, and you can do like this, right? All steps you can copy and paste here, right? And here, so finally I'm writing directly this one using this step, right? So see, this one already be approved, so I'm writing it directly, but you will not do because you may be penalized in terms of marks. All right, so according to the marks you can. Okay, so is equal. All right, actually we want to prove, okay, n plus 2 into 2 raised to power n minus 1. We want this one, okay. We need, okay, 2 raised to power n minus 1. Now focus how to get 2 raised to power n minus 1. Here already n minus 1. So let's bring, okay, 2 raised to power n minus 1. So I'm doing, okay, 2 raised to power n upon 2. And a problem, because if I have in denominator 2 raised to power 1, then I can get by log in this is 2 raised to power n minus 1, right? So I have multiplied and divided by 2. So simple trick, and plus n 2 raised to power n minus 1. Here already we have 2 raised to power n minus 1. You don't need any, okay, to do anything here. Is equal to 2 into 2 raised to power n. Here is 1 power, you can, n minus 1 plus n 2 raised to power n minus 1. Okay, so 2 raised to power n minus common. So n, okay, 2 plus n into 2 raised to power n minus 1 is equal to n plus 2. So it's also okay, but I'm writing according to the question. 2 raised to power into 2 raised to power n minus 1 is equal to right hand side. So simple, right? So I think, okay, now you have a problem, you enjoy it, okay? This question, now I think you are satisfied, okay, by doing, by looking, by watching this question, by understanding this question. Okay, so this question also done. I am happy because I have done 3 questions here. Okay, now I'm going to do the question number 4. Okay. Question number 4. Question number 4 is, I'm taking left hand side C0 plus 3C1 plus 5C2 plus dot 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 plus 2n plus 1 Cn. Okay, is equal to, and on the right hand side we have n plus 1 into 2 raised to power n. Okay, so firstly see the last term here, how we have broken the terms. Okay, last term will give you the hint. 2n plus 1 times Cn, 2 times n plus 1, this will be have broken, right? So see, C0 first, C0 you may write down, okay, no need to do anything. and here you can 3, okay, 2 times of n, 2 times of 1, so 2 plus 1, okay, C1, 2 times of 1 means 2 and plus 1, so 2 plus 1 is 3, like this way, the same point. Here is a 5, how to break, here n is okay, 2 times of n, here 2, 2 times of 2 means 4, so 4 plus 1, 5, 4 plus 1 times C2 plus dot dot plus 2n plus 1 Cn. Uh, I also think you have a problem here. Let's move into the next step. C0 plus 2C1 plus C1 and plus 4C2 plus C2. Okay. Uh, plus dot dot plus 2n times Cn plus Cn is equal to, now okay, now I'm going to write down, okay, C0, C1, C2 and Cn. I'm going to collect in one bracket here C0 plus C1 plus C2 plus dot dot Cn, okay, and plus, now thereafter, okay, I'm going to collect remaining terms, okay, remaining terms, okay, this one here 2C1 plus 4C2 plus dot dot plus 2 NCN, okay, is equal to here, as I told you just now, C0 plus C1 plus C2 plus dot dot plus Cn, right, sum of the binomial coefficients, okay, so sum of the binomial coefficients is equal to 2 raised to power n, so here I can write down 2 raised to power n. Here see 2 and 4 is multiple of 2 and 2n is also multiple of 2. So 2 you are getting, okay, 2 common from each term, right? And okay, 2 common here you are going to get C1 plus 2C2 plus dot dot plus and Cn. This one is exactly the first one question. Alright, so you can use, okay, same methods, okay, you can use, okay, same lines here, right, or you can expand, okay, depends on the marks, okay, right, so if it is necessary to expand, okay, then you should expand, okay, you should do completely, you should show the each and every lines for this question, okay. Here I'm writing directly plus 2 times, okay, already we have done, so that's why I'm using, okay, this result, n times 2 raised to power n minus 1, okay. So here, okay, 2 raised to power n plus 2n into 2 raised to power n minus 1 is equal to 2n. Okay, now let's see into the let's see the right hand side of the question number 4. Here 2 raised to power n. We need only 2 raised to power n. Alright, 2 is already in second term. Here 2 times 2 raised to power n. By law of indices, we can simplify these two. Here n and here 2 raised to power n minus 1 plus 1. I'm showing in detail. At this level, I don't so think you need to explain the law of indices also. N times 2 raised to power n. Here we are going to take 2 and common. Here n plus 1 or 2 raised to power n is equal to right hand side. So simply we got the right hand side. Okay. So I'm very happy because I have explained, okay, 1, 2, 3, 4 questions. I think you are also happy by watching this video. Okay. Let's see the question number 5. Now I'm going to write on the left hand side of the question number 5. Okay. So here we go. 5 number. Left hand side is, I think, C1 over C0 plus 2 times C2 over C1 plus 3 times of C3 over C1. Here 3 plus dot dot plus NCN over Cn minus 1. Okay. Alright, is equal to. Is equal to, now just, okay, as we have done in early question, here also we need to use the formula of this and this here in each and every term. Okay, C1 means NC, okay, N factorial over n minus 1 factorial, and 1 factorial c0 means n factorial over n minus 0 factorial and 0 factorial. Okay, and plus here also 2 times, okay, n factorial over n minus 2 factorial, 2 factorial. Here you may write down okay, c1. I also think this, okay, c0 c1, it must be c2. Okay, I'm going to make here c2. All right, so here also c2, by mistake I think I had written, and C2, here C1 means n factorial over n minus 1 factorial, 1 factorial plus 3 times, 3 times n factorial over n minus 3 factorial, 3 factorial. Here n factorial over n minus 2 factorial, 2 factorial plus dot dot, and the last term is n times n factorial over n minus n factorial, okay, here n factorial over n minus 1 n minus n plus 1 factorial n minus 1 factorial, right? So I think you are clear. Just I have used formula. Now, okay, n factorial over n minus 1 factorial, 1 factorial times here n factorial and 0 factorial over n factorial, right? No problem here, and plus 2 times of n factorial over n minus 2 factorial, 2 factorial times n minus 1 factorial over n factorial, and plus 3 times n factorial over n minus 3 factorial, 3 factorial times n minus 2 factorial, 2 factorial over n factorial, okay, and plus dot dot plus here, okay, I'll not get space, plus here I'm writing n factorial over n minus 1 0 factorial n factorial times n cancel 1 factorial and n minus 1 factorial over n factorial. Simple algebra I have used here, and cancel, right? So here n factorial means n minus 1 factorial. Here you will get only n minus 1 factorial, and plus here also cancel, okay, and 2 also gone, okay. Here you will write n minus 1 n minus 2 factorial over n minus 2 factorial, and plus n factorial cancel, okay, and 3 factorial, 2 factorial will cancel, and you will get here n minus 2 n minus 3 factorial over n minus 3 factorial, and plus dot 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 plus here n factorial cancel, right? Okay, n factorial cancel, here also n factorial cancel. You will have, okay, only this cancel, n minus over n factorial, okay. This is also n minus 1 factorial means n factorial, okay. I'm right, okay, is equal to cancel and cancel. So okay, I have a cancel, right? Why? Because n minus 1 factorial is also is equal to n factorial, that's why. So you will get here n plus n minus 1 plus n minus 2 plus dot dot plus 1 finally, right? You know, this is the, okay, expanded form of, okay, n minus 1 n minus 2, right, plus 1, and before 1 you will get 2, right? I'm going to write here in reverse way. I'm going to write 1 plus 2 plus 3, like this way you will get, and n minus 2 plus n minus 1 Surely you will get like this way, right? So if you see, okay, this one, these are the, okay, here you will see these are all, okay, natural numbers connected by plus sign, and here in what we can say, this is the sum of the first n natural numbers, right? So there is a one formula, okay, to find out the sum of the first n natural numbers in sequence and series, okay, we study. I think you might have a study. If not, okay, I'll try to make the videos on that also. And n plus 1 by 2 direct sum of the first n natural numbers, right, is equal to right hand side. So easy way, not so difficult. You have just apply the formula of this, formula of this, formula of this, formula of this, formula of this. Thereafter just simplify. You will get, okay, this line, okay, right, which is the sum of the first n natural numbers, right? So I don't think, okay, you have any problem. 1 to 5 we have done, right? In simple way we have done, okay. Now I will tell you the remaining, okay, right, questions. Okay. Question number 6. I'm starting from here. Solution. Here we will get, okay, all these things together. I'm not going to take left hand side here, right? This is a little bit different questions. All three questions are of same nature, right? Here 1 upon x raised to power n is equal to c0 plus c1x plus c2 x square plus dot dot plus cn minus 2 xn minus 2 plus cn minus 1 x raised to power n minus 1 and plus cn x raised to power n. This is expansion of this binomial, right? 1 plus x raised to power, and let's say this is the 1 again, okay. So again you have here option, uh, whether you have to write down. Option means, okay, we have to choose, okay, right, one correct one, okay, we have to choose, okay. So either, okay, first you have to multiply by itself, or you have to multiply by this one, expansion of this one, for c0 x raised to power n plus c0 x raised to power n minus 1 sorry, here 1, and this c2 xn minus 2 plus dot 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 plus c, and at last you will get, okay, cn, right? Okay, either you have to multiply first by this, right, this one, this binomial expansion, or you have to multiply by itself, okay. So it depends on the equation. Let's see, okay, right, we have to multiply by itself or this, okay. And one more thing, okay, these are the coefficients. These are the coefficients of one term. These are the coefficients of one term, whether you are getting or not coefficient of any term, right, one term. Now let's see. So if you multiply by itself, okay, so here c0 c2 you are trying to get, okay, c0 c2 c0, if you multiply by itself you will get c0 times c2, c0 c2 means, okay, x square, c0 c2 means you are going to get c0 c2 x square, right? And now let's see, okay, whether you are going to get, okay, these two are also coefficients of x square or not. c1 c3, c1 c3, here not c3, but you will have a c1 x c2 x cube c3 and c1 c3 x4. Hey, here, okay, this is the coefficient of x square, this is the coefficient of x4. As I told you, okay, these all are the coefficients of the one term, okay. So rejected, okay. So we are not going to multiply first by itself, right? Okay, so we need to multiply first by this expansion, surely, then definitely, right, then no need to check, okay. And for second also, c0, now I'm going to, you can use in the same way, c0 cn, c0 cn here, coefficient of x raised to power n, c1 cn minus 1, c1 cn minus 1, coefficient of, yeah, x into xn minus 1 xn, okay, yes. Here also in second question, in this question you have to multiply, okay, this expansion by itself, okay, in first, right, in second, in seventh question, let's say, yes, in sixth, okay, we have to multiply this one, and in seventh question, okay, you have to multiply by itself, right? And then last, okay, c0 square, So definitely not with itself, because C0 into C0 square, this is not the coefficient of any coefficient of, right, or any variable, right? So that's why you need to multiply with this. Okay, so done, clear. The in sixth number we have to multiply first expansion with this. In second you have to multiply the first expansion, okay, first by itself, and in third also you have to multiply by this expansion, right? So now let's see in proper way. I'm going to tell you here. Uh, Again you need to write down x plus 1, because if you have, okay, if you want to multiply, if you need, okay, this itself, so you can write down, okay, just again same and then multiplying, right? But okay here, but first one is not going to support expansion, so we need to expand, okay, expand this one. C0 x raised to power n plus C1 x raised to power n minus 1 plus C2 x raised to power n minus 2, and plus dot dot dot, finally you will write down, okay, Cn, right? Because if you do, and you will get C x raised to power n minus n means, okay, x raised to power 0, so only you can write down the Cn. So write down this one is 2, okay. Now multiplying, so very simple method, okay, right? So multiplying 1 and 2, we get, okay, multiplying first and second, 1 plus x raised to power n into x plus 1 raised to power n is equal to C0 plus C1x plus C2 x square plus dot dot plus Cn minus, okay, 2 x raised to power n minus 2, if you need, okay, otherwise, okay, simply you will write down, and Cn xn times so into C0 xn plus C1 xn minus 1 and plus C2 x raised to power n minus 2 plus dot dot plus Cn. Alright. So I also think now you have a problem. Now after this, okay, on the left hand side you have, okay, 1 plus x raised to power 2n is equal to, on the right hand side you will write on the same thing, no need to expand, okay, into this, okay, no need to expand, okay, same thing write down, okay. We are not going to multiply, okay, we are not going to in expanded form, okay, just you have to write down here, okay, on the left hand side you can simplify 1 plus x raised to power 2n. On the right hand side if you see, okay, you have to see this one also equation, this one, all right, you need to see this expansion, this, okay, left hand side of this question is C0, C2, C1, C3. So firstly determine, okay, these all coefficients are, right? So definitely all these, okay, binomial coefficients are the coefficient of some term, okay, single term, okay, which terms coefficient these are, right? Okay, let's try to find out, okay. So C0, C2, just here, okay, I'm using, because lack of space I will drop to write down here. So here I can C0, C2. C0 times this time this time this, C0 C2 coefficient of x raised to power n minus 2, whether you are getting or not, okay, C1 C3, C1 times this and this, okay, C3, here I have not written, C3 will be here, or this one we may write down C3 x raised to power n minus 3 plus and dot dot dot, okay, dot dot, okay, I have written, okay, no problem, we can write down. And now, okay, C1 times this, because of the C1 C3, okay, we will get here C1 times C3 x here power 1 x raised to power n minus 3, so x raised to power n minus 2 you will get, all right, so done. So this is the coefficient of x raised to power n minus 2. This is also coefficient of x raised to power n minus 2. This means, okay, these all are the coefficients of x raised to power n minus 2. So here, okay, after determining this thing, you can write down, okay, equating the coefficients of x raised to power n minus 2, both sides, okay, right? Both sides we get, alright, we get, so here 1 plus x raised to power 2n, one interesting thing, okay, C0 is the coefficient of x, C1 is the coefficient of x, C2 is the coefficient of x square, Cn minus 2 is the coefficient of x raised to power n minus 2. Alright, so exactly the same, okay, here. What will be the coefficient of this one? C of n means, okay, here 2n comma, here coefficients of x raised to power n minus 2, so n minus 2, n minus 2. Okay, so same, okay, r will be n minus 2 here, right? Is equal to, on the right hand side you will have all these coefficients. These all are the coefficient of x raised to power n minus 2. So without any confusion you can write down c0 c3 plus okay, c2 c4 plus dot dot plus cn minus 2 cn, right? Now here you will write down, okay, 2n factorial over 2n minus n plus 2 and factorial n minus 2 factorial, right? So same thing, okay, or you may write down here 2n, right? So you can write down here 2n factorial. So I'm okay, I think, okay, here so I may not get space. I have a space, but that may not come in video. So I'm writing here 2n factorial over 2n minus n. So n plus 2 factorial and here n minus 2 factorial is equal to c0 c2 plus c1 c3 plus dot 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 and plus, you may write down here, I am writing plus cn minus 2 cn. Okay, this way we can prove. Okay, so I also think you have a now problem here, right? So here also, but in this case, okay, you need to take again 1 plus x in 7 number, okay, you need to, okay, 1 plus x again and then check, okay, right? Whose coefficient one this and whose coefficient, but we need, okay, all these coefficients of single term, right? So here, okay, this one, okay, will not support, okay. Yeah, you need to write down the same. I have checked, okay, I have told you just now, right? So again write down, then multiply, right? And in 7th, okay, you need to write down in 8th number question. Firstly write down this expression, then again you need to write down, okay, let's check, okay, c0 square, c0, all right, coefficient of x raised to power 1, c1, okay, coefficient of x raised to power n, right? So simple, right? So here, okay, these all are the coefficient of x raised to power n, right? So here also I think coefficient of x raised to power n, you can check yourself, alright? So I have given enough hint to crack down these questions. Okay, so I think, okay, now after watching this video, you will clear all about the questions on binomial coefficients. Okay, thank you very much for watching my video. Bye bye.